The following video presentation is a part of a series of training aids that were developed for the Certified Aggregate Producer Program through the cooperative efforts of the Indiana Department of Transportation and the Indiana Mineral Aggregates Association. The sieve analysis is commonly known as the gradation test and is used to determine the distribution of aggregate particle sizes within a given sample. Gradation testing is necessary to determine compliance with the requirements of the Certified Aggregate Producer Program and Section 904.03 of the INDOT Standard Specifications. The gradation data may be used to calculate relationships between various aggregate or aggregate blends, to check compliance with such blends, and to predict trends during production by plotting gradation curves graphically, to name just a few uses. Used in conjunction with other tests, the sieve analysis is a very good quality control and quality acceptance tool. Please note the following. Accurate determination of material passing the number 200 sieve cannot be made with this test alone. This test is recommended to be used in conjunction with AASHTO T27 to determine the amount of material finer than the number 200 or 75 micrometer sieve. The sieve analysis for mineral filler is conducted in accordance with AASHTO T27. Particles larger than 3 inches should be hand-sieved. When passing large stones through sieves, do not force the aggregate through the sieve openings. The sieve analysis for dense graded number 43, 53, and number 73 aggregates require some additional steps to this procedure. Exceptions to AASHTO T27 and T37 are listed in Section 904.06 of the INDOT Standard Specifications. A general-purpose Class G2 AASHTO M231 electronic balance shall be used to weigh all materials for this test method. This balance is readable to 0.1 grams and shall have sufficient capacity for the size of the sample tested. Sieves shall be mounted on suitable frames designed not to leak and shall conform to AASHTO M92. If a mechanical sieve shaker is used, the shaker is required to provide a vertical or lateral and vertical motion to the sieves, causing the sample particles to bounce and turn so as to present different orientations to the sieving surface. Sieve shakers are required to provide sieving thoroughness within a reasonable time. An oven capable of maintaining 230 plus or minus 9 degrees Fahrenheit shall be used for this test method. When tests are performed in the field where ovens are not available, test samples may be dried in suitable containers over an open flame or electric hot plates with sufficient stirring to prevent overheating. Samples should be obtained in the field and reduced to test size in accordance with AASHTO T248. The sample weight of the material is determined by the size of aggregate in the sample. The original sample must be reduced to a test sample size which falls within the minimum and maximum weights in the following table. Samples are dried to a constant weight in an oven set at 230 plus or minus 9 degrees Fahrenheit in an electric skillet or over an open flame. Once a field sample has been obtained and split down to the proper test sample weight, the material is dried to a constant weight, weighed and recorded, and then placed into the top of a set of nested sieves. Depending on the type of sample, an appropriate shaker and sieves shall be selected for the shaking procedure. Every effort should be made to avoid overloading the sieves. The weight retained on each sieve may not exceed the allowable amount indicated in the following table. The sieves are nested in order of opening sizes, starting with the largest sieve at the top of the nest and ending with the smallest sieve at the bottom of the nest. A pan is placed below the bottom sieve. The sieve nest with the sample is then placed into an appropriate mechanical shaker and shaken for a period of time to ensure the sample is divided into the various sizes. The shaking time is also determined by the size of aggregate in the sample. The minimum mechanical shaking times are included in the following table. The actual shaking time is determined in accordance with ITM 906. Once the material has shaken for the appropriate amount of time, the material on each sieve and the pan is weighed and recorded. Before weighing the material, the weigh pan should be placed on the scale and the tare button should be pressed to a 0 reading or tare weight. Next, the material retained on each sieve and in the pan is weighed individually and each weight is recorded on the gradation form. For coarse aggregates, weigh each size and record each weight to the nearest 0.1 gram. Be sure to remove any aggregate trapped within the sieve openings by gently working from either or both sides with the trowel or piece of flat metal until the aggregate is freed. Banging the sieve on the floor or hitting the sieve with a hammer will damage the sieve. Once all of the aggregate has been removed from the sieve and placed into the weigh pan, place the weigh pan on the scale and record the retained weight for that sieve. This procedure is then repeated for the remaining sieves and the pan. For fine aggregates, weigh the material retained on each sieve size to the nearest 0.1 gram. Ensure that all material entrapped within the openings of the sieve are removed and included in the weight retained. This may be done using brushes to gently dislodge entrapped materials. The 8-inch or 12-inch round sieves need to be handled with special care due to the delicate nature of their screen sizes. As a general rule, use coarse wire brushes to clean the sieves down through the number 50 sieve. Any sieve with an opening size smaller than the number 50 should be cleaned with a softer cloth hair brush. Once all of the weights have been recorded, the gradation can be calculated. This concludes our presentation. Please consult your CAP training manual and respective test method for more detailed information.